Tonight on Revolutionaries.
Very often, technologists who are enamored with the positive aspects of what they have developed or are developing overlook the limitations.
Dr. John Holdren is the President's Chief Science Advisor. It's a big job. It covers everything from guarding against nuclear attacks to high-tech brain research. Tonight, Dr. Holdren talks about his wide-ranging portfolio with John Markoff of the New York Times. Major funding for Revolutionaries is provided by the Intel Corporation.
Do you think of yourself as a Californian?
Originally, certainly. I'm pretty much bi-coastal now, but yeah, I was raised in San Mateo.
How early did you come to Northern California?
At the age of 4. I was born in Pittsburgh, Pennsylvania. My parents moved to San Mateo when I was 4. I grew up in San Mateo, went to public schools in San Mateo, then went east to school to MIT, but I came back to Stanford for my PhD and my wife and I lived in California for 30 years as adults before moving east.
I read that you're passionate about fishing in the East, and so I thought, well, that's not backpacking in the Sierras.
Well, I was passionate about backpacking in the Sierras for the 30 years that I lived here as an adult, and even when I was a teenager, I backpacked.
So it's the way I wanted to start tonight. I too am passionate about backpacking in the Sierras, and there is actually a glacier in Northern California, not in the Sierras, but in the Trinity Alps. It's literally gone away in the 30 years that I've been hiking there. It's just not there. And so I wanted to begin with climate. And I wanted to actually begin with something that you said to the New York Times in 2007. To quote, you said, "I am one of those who believes that any reasonably comprehensive and up-to-date look at the evidence makes clear that civilization has already generated dangerous anthropogenic interference in the climate system." And then you add, "What keeps me going is my belief that there is still a chance of avoiding catastrophe." So here we are 6 years later. How are we doing?
Well, first of all, I would reiterate that optimism and say there is still a chance of avoiding catastrophe. We are not doing as much as we should be, not doing as much as we could be, but we are doing a whole lot more than we were 6 years ago when I wrote those words. The climate action plan that the President rolled out on June 25th in his speech at Georgetown University has a lot of the elements that we need in a national climate plan and in an international strategy. We actually, notwithstanding the inability to get a comprehensive climate law passed in the first 2 years of the first term, did get a lot done that was relevant, including the most forward-leaning fuel economy standards in the history of the country. Some of the most forward-leaning fuel economy standards in the world now being extended to heavy vehicles as well, making a big difference. Big boosts in investments in low carbon and no carbon energy technologies, a variety of programs and policies that have led actually to a decline in greenhouse gas emissions in the United States.
So you think that there's evidence that there is a link, that we've changed these things and you can see it in the
absolutely you can see it. Scientists can see it, but everyday folks in their experiences of the world around them and what they see on the television can see that things have changed. And the only question for folks observing that things have changed is whether humans are doing it or whether it's just part of a natural cycle of some kind. But the evidence is in fact overwhelming that humans are largely responsible for what we're experiencing. And the evidence is also overwhelming that it's already harmful. You know, in occasional pieces you see arguments about whether harmful interference in the climate system has already occurred, but in fact we're experiencing increases in heat waves, increases in droughts, in floods, in wildfires, very clearly linked by fingerprints of a variety of kinds to global climate change. We know, of course, that sea level is inexorably rising, that is causing increases in coastal property damage, increased damage in storms when storm surge is added onto the increased sea level. And of course, as you note, glaciers are going away over most of the planet.
I think I saw you quoted as saying that you felt global warming was a poor choice of words in a sense. That
I do think it's a poor choice of words. Global warming implies something, first of all, that's uniform around the globe, that is all about temperature, that is gradual, and that might even be good for you. There's sort of a sense of warming. How could that be all bad?
Yeah.
And the fact is, it's highly non-uniform regionally and globally for a whole variety of reasons. It's, for example, 2 or 3 times as fast as the global average at high latitude. So you're seeing in Alaska and around the high latitudes much faster change, and it's well understood why. It's not all about temperature. It's about all of the variables and patterns that make up climate. That means hot and cold, wet and dry, windy, stormy, when the snow melts, how fast it runs off. All of that is climate. And in fact, temperature is just a proxy, if you will, for the overall state of the climate system, in much the same way as your body temperature is a proxy for the state of your body system. You know, people say, well, what's a couple degrees centigrade, say 3.6 degrees Fahrenheit among friends? Well, if your body temperature goes up 3.6 degrees Fahrenheit, you know it's telling you something about the state of the system. It's not the temperature per se, it's the indicator that something is badly wrong. And similarly, if the global surface temperature goes up by 2 degrees Fahrenheit, it's not just the 2 degrees Fahrenheit on the average that we're experiencing, it's all the changes in circulation patterns and precipitation patterns and storm tracks that go with that should worry us.
Was there a recent report that suggested while the rate might be dramatic, that there's less concern about really dramatically disruptive things?
I don't think there's less concern about dramatically disruptive things. I think there's more. The latest report from the National Academy of Sciences, just out a few weeks ago, to me is a quite pessimistic report, noting that disruptive climate change, which is the title of their report, disruptive climate change can result not just from very rapid changes in the climate variables themselves, but can result from situations where gradual changes in the climate variables push ecological processes over a threshold. And so
that's what I was asking. Yeah.
You can have abrupt change resulting even from gradual changes, like changes in sea level, where a gradual change in sea level may lead to, after a relatively short time, saltwater intrusion in freshwater aquifers in coastal regions. Again, it can lead to major increases in storm damage. You have the situation with the coral reefs, where the coral reefs are the second largest reservoir of biodiversity on the planet after the tropical forests. And the coral reefs now appear quite unlikely to survive a global average surface temperature increase of more than about 1.5 degrees centigrade. And again, it doesn't matter.
At current rates, when will we cross that? How soon is that?
Probably 2035 or 2040. And of course, the coral reefs are subject to multiple stresses. They're experiencing ocean acidification, which is also associated with the buildup of carbon dioxide in the atmosphere, some of which ends up being dissolved in the ocean and producing carbonic acid. They're being subjected to overfishing. They're being subjected to physical damage by cruise ships that anchor and pull out a big chunk of coral reef every time they pull the anchor up. You may not think that's a big problem until you look at the number of cruise ships in the world and how often they anchor on coral reefs. But they're under assault from all of these things. And it appears that just from the standpoint of the combination of acidification and temperature, that the coral reefs will probably be close to finished by halfway through this century. That's very gloomy news indeed, not just because they're the source of a large part of the biodiversity on the planet, but because the other major source, the tropical forests, are also differentially vulnerable to climate change. We're in danger of drying out the Amazon.
So the most recent Mauna Loa number that I could find is 393.66, and I was wondering if you could explain that. Could you put a context around that number?
Well, the pre-industrial concentration of carbon dioxide in the atmosphere was around 280 parts per million, and now we're nearly at 400 parts per million. So in round numbers, we've gone up by some 40% in the concentration of CO2 in the atmosphere. But in addition, We've added more methane, chlorofluorocarbons, black carbon particulates that tend to warm the planet. We've masked part of it because we've also added reflecting particulates to the atmosphere.
But is there, I mean, in looking at that number, that single number, can you see a particular number that's a point of no return?
No, there is no red line that's a point of no return. You know, people have said, and in fact the G20 have agreed that we should try to avoid exceeding a global average surface temperature of 2 degrees Celsius above pre-industrial, and that is associated with an atmospheric concentration around 450 parts per million of carbon dioxide equivalent. That is counting not just the CO2, but the net effects of other warming and cooling things we add to the atmosphere. If it all adds up to 450 parts per million, you have about a 50% chance of staying below 2 degrees C above the pre-industrial level. And some people have concluded that because the G20 agreed on that as a target, that must be the red line, and below that is safe, and above that is dangerous. And that's nonsense, because we already are experiencing, as I've already argued, dangerous climatic effects at a CO2 concentration of under 400 parts per million, and a CO2 equivalent concentration that's not much different, because very roughly speaking, the reflective particles are currently canceling out the effects of most of the non-CO2 warming factors. And so the actual CO2 concentration, which is approaching 400 parts per million, is very close to the CO2 equivalent number. And again, with that number around 400, we're already hurting. Yeah. In addition, and this is something that relatively few people outside the climate science community understand, because of lags in the Earth's climate system, we are not yet experiencing the full climate consequences of the greenhouse gases that are already in the atmosphere. In other words, if we could stop instantaneously and hold the atmospheric concentrations where they are right now at, say, 400 parts per million CO2 equivalent, the temperature would continue to coast up from the current roughly 0.9 degrees C above pre-industrial to something like 1.5 degrees C above pre-industrial. So it may not be possible now to stop in time to save the coral reefs, but it is certainly possible to stop in time to avoid a lot of other consequences that we would be very unhappy about.
And so I wanted to ask you about strategies that we might pursue to make big changes here in the United States. Natural gas, there's been this dramatic change over a relatively short period of time. Is it right to think of natural gas as a bridge fuel?
It is right to think of it as a bridge fuel. It's not a long-term solution, because over the very long run, even natural gas causes too much CO2 to be added to the atmosphere. But in round numbers, natural gas emits about half as much carbon dioxide to the atmosphere as coal burning does per kilowatt hour of electricity generated by those two sources. And so substituting out coal with natural gas brings you a big benefit. It's just not big enough for where we need to go. You know, the president announced a goal of 17% below 2005 emissions for this country by 2020. Natural gas can help a lot getting to that goal. But the next goal that the president, I think, correctly announced was to get more than 80% below 2005 emissions by 2050. And you can't do that with natural gas. Yes. Natural gas emits too much CO2.
Even given the tremendous controversy about solar, the price has been falling dramatically, hasn't it? And can it step in and do something in a major way?
It has. Not only has the price of solar energy continued to fall, but we have actually quintupled the amount of solar electricity generation in this country since 2008. We have more than doubled the amount of wind electricity generation in this country since 2008, and wind is actually much bigger than solar at this point. Solar started from a smaller base, and so even though it quintupled, it's still not nearly as big as wind, which has doubled and some over this period. They're both getting less expensive. Our aim in the Sunshot Global Challenge is to make solar energy, solar electricity cheaper than coal. And I think that's entirely plausible by 2020.
So let me ask a hypothetical question. If you were a scientific advisor to a billion-dollar venture capital fund instead of your current role as the president's scientific advisor, with a 100-year time horizon and a goal of averting a dangerous level of global warming, and you had to pick one of the following as your top priority. Let me give you a list, and I mean, you're welcome to reject the idea, but would you invest in carbon capture, energy efficiency, including smart grids, nanotechnology, natural gas, next generation nuclear, centralized renewables, distributed renewables, or solar radiation management? Could you pick one?
No, I couldn't pick one. I would do all but the last.
Okay.
And solar radiation management, which is another term for geoengineering, is again something on which I would recommend doing studies to understand what we'd be getting into if we tried it. Again, one of the dangers there is grasping in desperation at solutions that are not solutions. If there are solutions there, we need to find them. And if there are only non-solutions there, we need to know it.
What was your personal route into climate issues?
I became interested very early on in my career as a technologist in the proposition that technological silver bullets, technological panaceas were being oversold. I was struck by a saying of one of the great physicists of the 20th century, Arnold Sommerfeld, who in 1946 said, by 1960, nuclear energy will have abolished poverty from the face of the earth. That's an exact quote. And of course, the fact that that couldn't possibly come true says as much about poverty as it does about nuclear energy. The notion is that very often technologists who are enamored with the positive aspects of what they have developed or are developing overlook the limitations. And so as a technologist myself, I thought it was my responsibility to try to understand not just what the opportunities and possibilities and potentials were, but what the limits might be. And early on in pursuing that idea, it became apparent that environmental limitations were among the most serious ones in the energy space. My own work when I was working on my PhD was on theoretical plasma physics, and the application that I was most interested in was fusion energy. And the story about fusion energy was that it will be infinitely abundant, dirt cheap, completely safe, no proliferation hazards whatsoever, and it will be the holy grail. And while I thought and still think fusion energy would be very much worth having, it turns out that it too has liabilities, constraints, and limitations. And my thought was, if we understand clearly what those are, we can work to minimize them during the design process rather than look for patchwork solutions afterwards. And about the time I was thinking these thoughts, a number of other much more senior and experienced people were coming up with studies which were reinforcing those views. For example, in 1970, there was a summer study done at MIT with researchers from all over the world called the Study of Critical Environmental Problems, asking, are there environmental problems that are serious enough to be considered really critical in terms of their impacts on human well-being? And they came up with a list of about 22, of which 15 were associated with energy supply. And it was already apparent at that time that climate change was likely to be the most problematic of all of the environmental impacts of energy, not least because carbon dioxide is not just a sort of a side effect, it's one of the principal combustion products of burning fossil fuels.
I was wondering about what kind of influence Sputnik might have had on you. You were 13, I think, when Sputnik was...
A big one, yeah. I was just going into high school, my freshman year in high school. And like everybody else, I could see this little glimmer, this little dot moving across the sky, and understood what it was. Certainly it had a big impact. I mean, I had been reading about space and rocketry and so on for years at that point, and I had been making solid fuel rockets out of my mother's used lipstick tubes in the backyard with chemistry set ingredients. But the actual experience of seeing Sputnik up there was very dramatic.
So your own career as an amateur rocketeer, how high did you how successful were you with your mom's lipstick tubes?
A couple 100 feet.
That's not bad. And so then, how did your first job was at Lockheed after high school? What led you to?
I had a Lockheed scholarship to MIT, and to my delight, the Lockheed scholarship included summer jobs at Lockheed. And the first one was right after my senior year in high school. Even before I'd started at MIT, I had a job at Lockheed in Palo Alto. And then in subsequent summers, I worked at Lockheed in Sunnyvale and got very wide experience of the aerospace industry in these various summer jobs.
Did you have to have a clearance then, even in?
Well, in fact, the first summer, right after my senior year in high school, the clearance I had was a company confidential. And I was working on putting parts together for the orbital programmer of the Midas spy satellite. The second summer, I was given a job. I now had a whole year of MIT Aero and Astro under my belt, and I was given a job in a group called Reentry Aerodynamics. And I didn't have a clearance at the beginning of the summer, but the first report I wrote, they classified secret, and they took all my notes away, as well as the report. And the third time that happened, they gave up and went through the rigmarole of getting me a clearance. So I had my first secret clearance at 19.
You know, we could talk for the entire hour about climate, but I wanted to ask you if you could point to some of the other important initiatives in OSTP now. I mean, if you had to sort of point to other high priorities.
Yeah, and I would name a number of them. And when you say initiatives in OSTP, I mean, these are really initiatives of the administration, initiatives of the president, in which OSTP has played a role. But a very big set of initiatives has been around the role of science, technology, and innovation in driving economic growth, in creating new businesses, new industries, new jobs, high-quality jobs particularly. And the president announced already in September 2009 a major initiative in innovation in which we basically asked, what are the underpinnings of an innovative economy? And we concluded, and the president rolled this out in September of 2009, there are a whole set of foundational elements that we need to invest in. One is basic research and the institutions that do basic research. One is science, technology, engineering, and math education, STEM education, where we concluded we have to lift the country's game in STEM education, both to get the high-tech entrepreneurs and the inventors and the discoverers of the future, but also to get the tech-savvy workforce that the 21st century economy requires. Another one of the foundations is the forms of infrastructure that are relevant to innovation, and that includes, of course, information technology, computing, monitoring, space technology, a whole set of infrastructural elements, broadband, wireless, and so on. And the fourth foundational element is the political and economic environment that is not only receptive to, but nurturing of entrepreneurship and innovation. And the administration proceeded then to construct specific initiatives focused on these various foundational elements, a whole set of initiatives in STEM education, a set of initiatives in information technology, in making high-speed broadband more widely available, a whole set of initiatives around making government data more accessible, more open, and in usable form, so entrepreneurs could build businesses and develop new services based on the availability of these enormous data sets that the taxpayers had paid to create. We've had major initiatives in health information technology, figuring out how to use IT to get better outcomes for more people at lower costs. We've had, of course, major initiatives in the energy space. We've had an advanced manufacturing partnership, which is looking to the private sector, the academic sector, and the government to work together to figure out how to bring back manufacturing in the United States using advanced technologies, IT, robotics, nanotechnology, other dimensions of material science, synthetic biology, the so-called bioeconomy.
Do you think, beginning in the late 1980s, industrial policy became a real political struggle on Capitol Hill.
And we don't call it that anymore.
I know, and the term went away, we still fight over choosing winners and losers. There are lots of fights, but do you think that, if you look at it from Silicon Valley rather than from Washington, it's clear the government played a role, but often the role feels very serendipitous. It doesn't feel like innovation can be planned frequently, although it clearly has had a role.
Well, it can't be planned and shouldn't be. But what we understand very clearly now is that a fundamental role of government is to support basic research, which is research at a stage before you can determine what the outcome is likely to be, what the implications are likely to be,
right.
What products are likely to emerge from it. It's very well understood by economists why the private sector will never invest in basic research to the level that society's interests require. Yeah. The risks are too high, the outcomes too uncertain, the potential returns too distant, the findings not always appropriable. And so we know that government investments in basic research have been enormously important over the years. It was NSF grants to a couple of Stanford graduate students named Larry Page and Sergey Brin, which ultimately led to the company we all know, very close by, yeah. With, last I looked, $270 billion in market capitalization, tens of thousands of employees.
Classic serendipitous investment.
And so on. If you were to ask Charles Towns, as he was sitting on a park bench in Lafayette Square in Washington, D.C., thinking about the maser, which was the predecessor of the laser, Charlie Towns had absolutely no idea that the technologies that grew from this area of basic research would be how we cut metal, how we copy, how we determine distances, how we listen to music and watch movies. It would be insanity. Yeah. For Charlie Towns to have envisioned that. But it was government investments in that kind of research. Look at the genomics revolution. Government investments. Look at, you talked about natural gas and fracking. Look at seismic exploration, horizontal drilling. It was government investments, even in that area of practical application, right. That then led to oil company investments, that then led to the development of technologies that actually worked.
Do you worry that the DARPA of today, for example, that has funded many of those crucial innovations, is a very different beast than the DARPA of the 1960s, which was committed to just very blue sky things without a lot of restrictions on the research? Now there are milestones and benchmarks, and I know that people...
Well, this is partly, a reaction to the dilemmas of funding. That is, when money is tight, everybody wants accountability. And doing high-risk, high-return research in that environment becomes more difficult. But this administration is committed to doing high-risk, high-return research, having the government fund it. And while there was a period in which DARPA had shorter-term focuses and less out-of-the-box thinking, they've really moved back into the outside-the-box thinking, into the high-risk, high-return stuff, at the instruction of the administration. President Obama is remarkably sophisticated about these matters. He understands the importance of basic research. He understands the importance of being willing to try hard things and sometimes fail. And he's willing to continue to back it, and he has backed it in the budgets that he has produced.
So out of this budgetary process, how much at risk is basic research funding in these budgets? What does it mean?
I regard that situation as a glass that is both half empty and half full. Basic research budgets are not as big as I think, or as the president thinks, would benefit the country. At the same time, we have done better at protecting basic research in a difficult environment than might have been expected. Indeed, research as a whole and basic research have done better under these really very difficult funding constraints than virtually any other sector you can look at. And it's again because the president understands it. When the president went to the National Academy of Sciences just a few months after being inaugurated the first time and spoke at the annual meeting of the National Academy, he was the first president since JFK to do that. And he devoted about 2/3 of the speech to the importance of government investments in basic research. You know, I think most people expect that the president's going to come, he's going to talk about science and technology in the economy, science and technology in energy, science and technology in health. He spent 2/3 of the time talking about the importance of basic research to all of these domains. Basic research as the generator of the insights on which all applied technology and development in the future would draw. And he's been true to that in the budgets he's put forward. We haven't always gotten it all through the Congress. You know, one of the things that's quite striking, the Department of Defense, which is about as applied an agency as you can find, has been spending in this administration over $2 billion a year on basic research.
I wanted to ask you about space exploration. One very pragmatic question and one more philosophical. Mining for asteroids. Is it worth it as a goal from an economic point of view?
Far from clear. It is interesting that there are some private operators who are interested in that possibility. There are, however, obviously a number of reasons for being interested in technology relating to be able to not only identify asteroids on a collision course with the Earth, but be able to manipulate their trajectories. Because as we were reminded not so long ago, with an impact in the range of 500 kilotons over Siberia, asteroids do from time to time strike the Earth. Some of them are big enough to do damage on the surface, and some of them, like the one that hit 65 million years ago, are big enough to exterminate most life on Earth. And in order to prove that we are more intelligent than the dinosaurs, it would be prudent for us to figure out how to avoid such an outcome should a large asteroid on a collision course occur in our lifetimes.
So we're still pursuing the notion of sending a man and or women to Mars. Wouldn't it make more sense to invest in the kind of artificial intelligence technologies that could do that mission without humans? Because not only would we get there and do the mission, but we would probably get spin-offs that would be dramatically valuable on Earth.
Well, we get spin-offs out of virtually everything we do in space, including there have been many spin-offs from the human space exploration program we've had. It is an interesting controversy about robotic versus human exploration. As in some other areas we've talked about tonight, I myself am in favor of a portfolio. I think the robotic missions are enormously important. They're effective. The Curiosity Mars Science Lab, the rover that has been crawling around the surface of Mars, making extraordinary discoveries, is a great example of the potential of robotic missions. Yeah. I had the pleasure of being in the control room when Curiosity landed. It was a gut-wrenching experience.
It was.
During the period when we knew, because of the time lag in the signals getting here, it had already either successfully landed or crashed and burned, and we didn't know which. I mean, it's fabulous stuff. These robotic missions. Yeah. But there are also things that humans can do and ways in which the human exploration of the solar system fulfills a fundamental desire in the human race to explore that make it worth doing. Yeah. And so, again, my answer is all of the above.
I wouldn't have brought this up, but your staff did. Apparently there's new information about Area 51. And I was wondering if you could tell me what we know now about Area 51 that we didn't know before.
What a question. You know, I was mentioning backstage that I've had the good fortune to know personally every science advisor to a president of the United States since George Kistiakowsky, who was Eisenhower's second science advisor. And every one of these folks, were they all still alive, would tell you that as soon as they get into office, they receive a spate of letters, more recently a spate of emails, demanding the truth about Area 51. Admit that there are alien bodies buried there. There are no alien bodies buried in Area 51.
It's really disappointing to learn that.
I'm so sorry, but
well, to pursue the alien theme, you know, every time we turn around, there are more Goldilocks planets discovered. I mean, it's just extraordinary.
It is extraordinary.
And you're probably familiar with the Drake equation.
I am.
And are you puzzled? And we're 2 miles, maybe a mile and a half from SETI's headquarters here. Are you puzzled why we haven't had you know, why, if there's so many hospitable planets in the universe,
haven't we heard from
anybody?
anybody?
Well, haven't we heard from anybody?
Well, you know, there was actually a very interesting paper written some decades ago now on just this question. The title of the paper was, "Where is Everybody?" and a number of hypotheses were put forward for why, given the odds that intelligent life must have developed in a number of different places in the universe, just as a probabilistic matter, why haven't we heard from anybody? And one of the hypotheses was that although intelligent civilizations do develop elsewhere from time to time, they have a very short half-life after they develop nuclear weapons. That a large fraction of the civilizations that develop exterminate themselves in fairly short order. Another hypothesis is they quickly learn that it's a bad idea to advertise their presence. And so they do all their communication with fiber optic cables rather than sending radio signals around that could propagate and lead to a predatory civilization finding them and devouring them. So, I mean, obviously nobody knows the answer to this question, and nobody knows whether the probabilistic equation is really right, because we don't really understand enough about exactly how life began to be confident that it has arisen a huge number of times elsewhere in the universe. But again, based on what we do know, it does seem awfully likely that there is life elsewhere in the universe, and if there's life, there must, in some circumstances, be intelligent life.
Yeah. I wanted to ask you more about robotics. One of your initiatives was on collaborative robotics, building machines that could work effectively with humans. Last year, when I was reporting about the growth of manufacturing robotics, I took a very interesting tour at a Flextronics plant that makes solar panels in Fremont. They had a big sign on the wall that said, because Governor Brown was about to visit, bringing jobs and manufacturing back to California. And I did a careful count of the number of people who were on this very automated line, and there were 9 people.
I think I read your your article or your blog about this.
And so it's a difficult, I mean, it's a good news, bad news potential situation. I certainly would not criticize your initiative, but you know, we may end up with an economy that actually doesn't have more jobs, even though it's more productive and more competitive internationally. And I wonder if you've looked at that challenge.
Well, first of all, this is certainly outside my domain of expertise. I'm very familiar with the challenge, and certainly aware that the composition of employment is constantly changing. That is, we have far fewer jobs in agriculture now than we did 100 years ago in this country. And that's partly due to mechanization, obviously, and other ways in which productivity in agriculture has increased. But the unemployment rate on the average is not much different than it was a long time ago, because many other kinds of jobs have materialized, and the people who once were doing agriculture are now doing other productive things. And I think the same thing is true in many of the manufacturing fields, is there will be certainly jobs for people who can work with the high technology processes that are involved in modern manufacturing, but there won't be as many of them as used to exist on assembly lines that were mainly populated by people. And there will be, at the same time, jobs in other industries. I mean, look at information technology. Where was information technology 30 years ago?
Yeah.
And where is it now in terms of the number of jobs
No, to your Google point, I mean, who would have thought that there would be this job category called search engine optimization,
Yeah,
which
right.
employs hundreds of thousands
Exactly.
of people? Yeah, you know, most people, the name John Poindexter hasn't come up much in this current round of negotiations, which kind of surprises me because Poindexter, for all he was vilified for in originally developing the Total Information Awareness Program, had this notion that somehow you could square the circle between big data and individual privacy. And he actually brought a large number of computer scientists together in an effort to see if there was a way to do that. Nothing came of it, but it seems to be a pressing challenge for the technologists.
It is. There's an enormous challenge there. And it's one that we have looked at in many of its different dimensions. For example, relatively early in this administration, the President's Council of Advisors on Science and Technology, PCAST, did a major report about health IT. I mentioned in my quick catalog of some of the things that the administration has done in initiatives in science and technology is in the health information technology domain. And a very distinguished group, not just members of PCAST, but a larger working group that they assembled, grappled with this question of just in the health domain, of how do you get the benefits of more rapid and complete sharing of patient medical records between patients and physicians and between different physicians who are treating the same patient, and how do you get the benefit of knowing what has worked and what has not worked in trying to address maladies that are afflicting millions of people. Mm-hmm. How do you do all that while protecting privacy? That's already a big challenge. I mean, leaving aside the national security and anti-terrorism and national intelligence space, just in the health IT domain, it's a huge challenge. A lot of effort has gone into figuring out how to do that, and there will need to be more effort still in this whole big data domain across all of its applications if we're to successfully get it right.
I want to turn to these, but before I do, I just have to ask you about my favorite PCAST report, which was done last year, and it was on the issue of spectrum and using spectrum in a modern way with computation. And what struck me about reading the report at the time, I can't remember the specific numbers, but the notion is you could so much more efficiently use spectrum that it would basically have one of these indirect serendipitous effects and perhaps recreate in the mobile wireless world the kind of economic boom that we had with the internet. Do you remember that report?
Oh, absolutely.
Have you made
Absolutely, I remember the report. There's been a huge amount of follow-up to that report, a huge amount of interest in it in industry and in government. The new FCC chairman, Tom Wheeler, is very interested in moving forward with this. There's been a lot of action since the time of the report.
I think we could find 1,000 megahertz free somewhere to run the experiment.
The most fundamental proposition is not just that spectrum today, while it seems to be running out, there's only a finite amount of it, and there seem to be exponentially increasing demands for it, right. Particularly because of the enormous success of broadband wireless. So the sort of the initial position is, well, we look around and we see what parts of it really aren't being all that intensively used so that we can reallocate it more efficiently. But there's a much more scientifically interesting and more fundamental idea in spectrum sharing, in that the kinds of technologies we know how to build today can basically allow multiple users to use the same spectrum without interfering with each other. And that is the proposition that underlies the most forward-leaning recommendations in that report, and the ones that we're most interested in seeing implemented in the decade ahead. That is the insight that will turn a situation of scarcity in spectrum into a situation of abundance.
Is the White House looking into any long-range programs like the National Highway Program or the Apollo program?
Well, that sort of brings up the question of grand challenges. I mean, the Apollo program was a great example of a grand challenge. President Kennedy says we're going to go to the moon, put humans on the moon by the end of the decade. We have a number of grand challenges underway now. One is the sunshot. Let's make solar energy as cheap as coal. Another is EV everywhere. Let's make it attractive and technologically and economically practical to have electric cars everywhere that provide the same performance and convenience of transportation that gasoline-fueled cars do today. Another grand challenge is the BRAIN initiative, which the president announced last year, in which, for a multitude of purposes, we're bringing together multidisciplinary teams and a diversity of approaches to better understand how the brain works, to better map the brain, to understand the functioning of large groups of neurons acting together rather than simply looking at neurons one at a time. We'll never understand what the brain does until we can do that. This is an enormous challenge. You know, the Human Genome Project was a grand challenge, which, by the way, it's been estimated has returned $140 in economic activity for every dollar the government invested. Sort of getting back to this question of the relation between basic science and ultimate outcomes for the society. So we are actually very enamored in this administration of the power of grand challenges to inspire, to energize, to get people working together in pursuit of a big, inspirational common goal.
How do we value STEM education? How does it correlate to compensation for teachers and educators?
That's actually a great question, and the answer, first of all, is we don't value it nearly highly enough. We don't value education in general highly enough, particularly at the K through 12 level. There was just another report that came out in the last week or so trying to look in detail at why countries that do better than the United States, Singapore, Finland, South Korea, what are they doing differently to get such superior outcomes in standardized tests in science and math? And one of the answers that emerged from this comparative study is that virtually all of the countries that do better than we pay teachers much better than we do.
Shock.
They make, teaching is a very high prestige position, and it's suitably compensated in terms of the salaries of teachers and principals. I mean, this is a very fundamental insight. And of course, there is a challenge associated with this, that in most of these countries that have done this, education is controlled by the national government. So they can make a decision as a country as to how they're going to do this. In the United States, of course, education, K through 12 education, is largely in the province of the states and communities. And so it's a harder thing to wave a wand and say everybody is going to pay teachers better.
Put the National Science Foundation budget into perspective relative to other nationally funded programs. Then rationalize it. It's tiny.
Well, let me say a couple of things about that. The National Science Foundation budget is about $7.5 billion a year. The NIH budget is about $30 billion a year. And the DOE Office of Science is about $5 billion a year. Science at NASA is about $9.5 billion a year. If you look at the whole federal science budget, applied and basic research, but not development, it's about $64 billion a year. Now, is that enough when the military budget is, in round numbers, $500 or $600 billion a year? Should we be spending more on science? A lot of us think so. But anybody who reads the newspaper or watches the television knows that we have a very challenging budget situation in the government. Reaching agreement between the parties on what the budget should be and what the priorities within it should be has been an enormous challenge.
When I looked at international research and development spending comparatively, we spend far more than any other country.
We are by far the biggest.
I was actually kind of struck. But and then
well,
you get
public and private, we spend over $400 billion a year on R&D.
Yeah.
And one of the things that most people don't recognize, unless they're geeks who study these statistics, is that industry funds about 2/3 of all the research and development done in this country. Of course, they are heavier on development, and the government is heavier on the basic research, and applied is more evenly split. But we do spend more than any other country. China is catching up.
They're number 2.
China is number 2,
yeah.
and China has been increasing its R&D expenditures by something like 20% per year, which a little arithmetic reveals will lead to them catching up and surpassing us unless the pattern changes in not very long.
Should we worry about something like the fact that they have the world's fastest supercomputer now? Is that a fact of national concern?
Well, I would say a couple of things about that. Certainly the Chinese are going to be increasingly formidable competitors in the IT space. But people who think about supercomputers know that the particular metric on which China currently holds the record is not a particularly informative metric about the real capacity of high-performance computers.
Yeah.
And the capacity to handle big data is, in fact, probably more important today than pure floating point operations per second.
I know a group of people who are trying to find a way to run that benchmark on a cluster of iPhones. And so maybe we can, if you get enough iPhones, maybe we can reclaim the...
Well, you know, it was mentioned then in that little film at the beginning, interestingly enough, about how your phone is 1,000 times more powerful than an IBM 7094. I was the operator of an IBM 7094 at Lockheed in the early 1960s. That was my summer job for one summer. And I've kept track ever since of the power of the computers I was using compared to that 7094. And the last I looked, my laptop was equal to 5,000 of them.
Oh, yeah.
I mean, it would take it's interesting because the IBM 7094 was a big enough computer to handle our thermonuclear weapon design challenges at the time, a big enough computer to do the orbital mechanics for the moon mission, and so on. And it would probably take 6 months to boot Windows 8.
Yeah. Well, this has substantially more power than the Cray 2 I visited at Livermore. Yeah. It's substantially more power.
It is stunning.
In 1986, I think it was.
The difference is really stunning. Yeah. The fact that we've all got supercomputers in our pockets.
Yeah. Let me make this the final question. It's quirky. I'm not quite sure how to interpret it, but if we switched from income tax to a carbon tax, the whole country would be motivated to fix the issue. Comments?
You know, in Washington, the T word is anathema.
Of any kind.
And I will only point out, therefore, that every economist who has studied the issue concludes that it is more efficient to tax bads than to tax goods. And if you believe that income and capital gains are good and carbon emissions are bad, and if you believe the result that every economist reaches, then we would be better off as a society if we taxed income and capital gains less and taxed carbon more. But that is not to comment on the political feasibility of doing that anytime soon.
Well, thank you for coming this evening. I really appreciate it.
The Office of Chief Science Advisor to the President was created by Franklin Roosevelt. The first advisor was computer pioneer Vannevar Bush. There are hundreds of stories like this at the Computer History Museum. Join us next time for the Computer History Museum presents Revolutionaries.